Okay, guys, so we'll continue with some more topics, which I have. I don't have the labs for that, or we can just get introduction to those and the concepts about that. But whoever wants to do the lab, I can just put the link, step-by-step link of doing that. Hopefully, the previous ones were all done or repeated as well. Those are all we use in the projects and in the job environments and data centers. So high availability and disaster recovery technologies as well as maintenance and management. So if we go ahead, so I'll be putting more stuff here, material there as well. Some of the stuff we have already gone through, but the stuff that we haven't, I will just go through that and fly by or have a quick review of what we have already done as labs. So that was also a lot of material, a lot of options there that during the lab we were seeing multiple options. So terminologies were related to those options were also on the in the features there as well used. So first I will be just it's about virtual machines. We have talked about virtual machines. We have created those virtual machines, and so I'll just go for which ones we haven't covered. OVF we have covered also, but the ones that we need to talk about, I'll just go ahead. And in fact, this one has majority of the stuff covered, and I'll be visiting it back. But let me just go through the monitoring there. Okay, so virtual CPU and memory concepts, resource controls, resource monitoring tools, monitoring resource use, using alarms, and resource management and monitoring. So uh, after completing this lesson, so yeah, we need to just check that how monitoring really works inside uh, vCenter. So memory virtualization basics. vSphere has the following layers of memory. Yeah. Oh, okay. I thought that was a question. So vSphere has the following layers of memory. Guest OS virtual memory is presented to applications by one operating system. So guest OS virtual memory, the vmem, or when I was saying that, okay, let's just give it 1 GB memory. So that is the memory. Guest OS physical memory is presented to the virtual machine by the VM kernel. So whatever underlying physical memory is there is presented to the virtual machine. Suppose we have 128 GB RAM. You have given 1 GB RAM to a virtual machine or test virtual machine. So from 128, that much RAM will be provided. Host machine memory that is managed by VM kernel provides a contiguous addressable memory space that is used by the VM. So yeah, this is what we're talking about. That the physical memory is there. Then the guest OS physical memory. Guest OS requests that much memory from the physical memory, and the virtual memory then is translated to applications. So when we were allotting this whole memory, then we did talk about that before as well. But some of it, obviously, as a theory, we need to revisit. So VM memory overcommitment. Memory is overcommitted when the combined configured memory footprint of all powered on VMs exceeds the host memory sizes. So overcommitment just means that you have, as for example, 128 GB memory, and the virtual machines you need even more than that, 128 GB memory. So in that case, overcommitment happened. So VMs do not always use their full allocated memory. So not all VMs always use whatever was allocated. So this VM virtual machine was allocated 10 GB, 10 GB, 10 GB, 10 GB, right? So it's not compulsory that it would be always using 10 GB. Maybe it is using actually 5 GB majority of the time. And this last one actually needs 12 or 16 GB, or sometimes 24 GB. So whatever memory, and these two normally average, as an average, are using 5 GB memory only out of 10 GB. So in that case, um, this machine that needs more memory, and these machines that needs actually less memory. So how does it all really gets managed? So to improve memory usage, an SXI host transfers memory from idle VMs to VMs that need more memory. So memory is in the background transferred. Overcommitted memory is stored in the .vswp file, and memory overhead is stored in the vmx asterisk .vswp file. So these are overcommitted memory. Whatever memory has been given more than what is actually available is stored here, and then whatever memory overhead, so what is needed, is stored, or that information is stored here. So how does it manage that one virtual machine needs a lot and others actually don't need a lot? So in that case, there are some techniques there. Any SXI host uses memory over commit techniques to allow the commitment of memory while possibly avoiding the need to page memory out to disk. So before the memory is being paged out, so disk paging, we know from Windows that concept, that you're using the disk, some of the disk area as a memory. So before doing that, that's also called swap file here. So before doing that, can the memory be still managed on top of the overall that RAM capacity that you have? Can it be managed after that? If it's still not being able to manage, so then go ahead and use the page file or to do this. So there are methods used by the SXI host to manage overall memory, that one machine needs more, others need less. So how do we really manage that? So transparent page sharing, this method economizes the use of physical memory pages. In this method, pages with identical contents are stored only once. So this is overall whatever memory is. So the unit of that memory would be page where the data is stored, and that would be managed by the ESXi host. That whatever is available, just store it in the memory, and whatever is needed, then make it available for the other virtual machine. Ballooning, that has been a common concept, which in the previous slide have been mentioned. This method uses the VMware Tools balloon driver. So there's a inside the VMware Tools. VMware Tools have all the advanced options or advanced configurations there. So VMware Tools balloon driver to deallocate memory from one VM to another. So that is exactly, while two virtual machines are working, some memory from the virtual machine that is not using it can be transferred automatically to the other virtual machine that is in need of it. So the ballooning mechanism becomes active when memory is scarce, forcing VMs to use their own paging areas. So the thing is that ballooning would simply, as the method says here, deallocate memory from one VM to another. Memory compression. So this method tries to reclaim some memory performance when memory contention is high. So this is just again reclaiming some memory from those machines which are not using it, and making it available for others that really need it. So another method for that, to compress the memory to keep more of it available for when it is really needed. Host level SSD swapping. So use of a solid state drive on the ESXi host for a host cache swap file might increase performance. This is obviously the page file you're using some part of the disk to actually as a memory. So this is it's just terminology is this. So VM memory paging to disk. So host level SSD swapping, it's available, and then there's VM memory. Using VM kernel swap space is the last resort because of poor performance. So VM kernel, basically the kernel of the E6i as well, would really help the virtual machine kernel. Kernel just is that software, that mechanism where you have, the need of the hardware is virtualized, abstracted, and the virtual machine thinks that it's on an actual physical hardware while it is on a virtual one. So VM kernel swap space is the last resort, which just means that whatever, sometimes it's not sometimes, normally E6i has some swap space or some space dedicated for the purpose of lending it as a memory. So that is normally it saves it. If nothing else works, then okay, I have some more spare space there that I can really offer you. Then it goes to VM memory paging to disk. So it has just some last resort saved space for swapping or using disk as a memory. So these are some of the methods there, which pretty much overall does one thing, and that is to make available make available the memory to those machines which you really need it during peak hours, from those machines, either from those machines which are at that time not in need, and then giving them back as well, and also to use the paging on the disk or swap file on the disk. So these are the two methods, or these are some of the methods that will keep the memory supply available for those which are really in need of memory. And so that's memory overcommitment related configurations. Then there is configuring multi-core VMs. You can build VMs with multiple virtual CPUs, vCPUs. The number of vCPUs that you configure for a single VM depends on the physical architecture of the E6i host. That's pretty straightforward, that you are just making available the vCPUs according to what you have in the underlying hardware, and so the vCPUs normally when you make them. So this is the virtual side, this is the vCPU, and then there's physical side, there's thread, core, and socket. Normally how many cores are there, and then the threading is going on, and how many sockets are actually available. If I go to task manager of my Windows 10 laptop and go for performance, and in CPU, if I click the CPU, so normally there's the sockets. There's one socket, cores 4, and logical processors 8, right? And then there's L1 cache, L2 cache, L3 cache. So cores would just be physically, there's one socket there, one processor, physical processor there, and it's divided into cores, dual core, quad core, and then it is further, the core processors can be divided into logical processors, with the help of threading, or so this threading process actually just further divides the cores into more independent processors available for the applications to use them. So how much of the cores are given to or assigned to a single virtual machine? So we've been assigning obviously two vCPUs or one vCPU actually for our test environment, but in production environment, suppose you have databases there installed that will use a lot of processing. So you should go for 4 vCPUs or 6 vCPUs even to use more of the processing from the underlying quad core, or actually 8 core or 16 core or 32 core processors. For big servers, normally you would increase the cores when you're really hosting a lot of virtual machines there. So that issue is not that much when you go to cloud and create a virtual machine. When you create a virtual machine here, you have to know what is the underlying hardware I have. And while in Microsoft Azure Cloud, the underlying hardware is provided from Microsoft or from AWS, Amazon, or Google Cloud. But if you're talking about VMware Cloud, so that is also, you download the software and on top of a hardware, and that hardware you need to manage yourself. So with vCloud also, you need to just check that how much underlying processing we have, so we could just host as many virtual machines, and whatever virtual hardware we're assigning, that it will be asking that processing and memory utilization from the underlying hardware. So we have to just keep an eye on what we have and what we are giving basically to the virtual machines. If About hyperthreading, so with hyperthreading, a core can execute two threads or sets of instructions at the same time. So that would be just, if we go ahead and check it. So if I go for a processor socket, so that would be, I'm sure you have seen enough of these processor sockets here, and I'll just grab one picture, and it's a straight one. Okay, so I'll just go for this one, and so it would be just 4 core would be, if we have, I cannot make lines, yeah. So there are 4 cores, right? So, and if so this means that one physical processor has that one core here, one core here, one core here. Quad core would be further divided, and that would be then more of that, and hyperthreading would even further divide that. So these, if there are 4 cores, then the hyperthreading would further divide it into 2 more independent processor. This processor receiving application requests independently, this side receiving independently, this side receiving independently. So logically, you then have 8 processors there that are independently, simultaneously receiving requests from applications. So multi-threading just lets you have just more processing is available with the help of multi-threading. It just divides the core into 2 independent processors that are receiving your requests simultaneously now. So hyperthreading or multi-threading. So hyperthreading provides more scheduler throughput. Hyperthreading is enabled by default. To enable hyperthreading, verify that the host system supports hyperthreading. So obviously all the new hardware, underlying hardware, would support that, and enable hyperthreading in the system BIOS. If it is not enabled, from VMware it is enabled, but to use it. But if suppose you got the HP or Dell hardware, does it really support it or not? Oh, if it's not supporting it, go to the BIOS and enable it. Suppose it's disabled. Ensure that hyperthreading for the A6i host is turned on. So that's something, sometimes it is actually turned off, and the performance overall is a bit lower, and sometimes there is a warning, okay, hyperthreading, do you want to turn it on for better performance? And sometimes we just have to figure it out that, okay, what else is not configured here that is giving us degraded performance. So CPU load balancing, and the VM kernel balances processor time to guarantee that the load is spread smoothly across processor cores in the system. So obviously it would not overwhelm all the load coming from one virtual machine the CPU load from all four machines. Suppose these all four machines really need a lot of CPU processing, and that is being sent in a load balanced manner and divided manner, that all the machines requests are tackled properly, and not one no one machine is actually overwhelming the whole all the cores of the processor, and others are just requests are still in the queue. So obviously CPU load balancing, that just applies for everything else as well. The memory, the bandwidth, and the disk IOPS, input output data per second, that it's all load balanced, and all virtual machines requests are really sent simultaneously to the processor, and one of the machine's requests is not overwhelmed. So other than that, if we go ahead with resource controls, so there is we talked about that, reservations, limits, and shares. We did the lab for that too. That's available capacity, limit, reservation. So we're gonna go ahead a little, because we did the lab. You can just refer to that lab as well. What's going on? Resource allocation, resource pools we created, VApps we created, and then those resource pools were uh, deleted when we enabled the DRS, and we've gone through a lot of features of DRS there as well. That's what we have discussed already here. Resource allocation, reservation. So reservation, just a small review of this is that availability capacity limit is called the how much maximum you want. Reservation is how much minimum you want, and then there are shares that ESXi, if your virtual machine resource pool shares are more, ESXi will listen to you more, or first your priority will be on the top when ESXi is ready to allocate resources. Resource allocation, reservations, yeah, reservations. So we talked about that already. Allocation limits, so RAM limits, CPU limits. Obviously, resource pool goes for two most sought after features or resources, which are CPU and memory. So you can put a limit and reservation of both for specific or critical virtual machines there. And resource shares, so we talked about that. The more share number is there, the more that machine will be prioritized to give to be offered the CPU and RAM resources. So we can increase that, but we have done all that lab, so that's why repeating it all would be just you can just I'm going to be uploading these as well. When you start the preparation of exam, you will have enough material plus the video lectures. So I'll go for the next one, which is resource monitoring. So there's performance tuning methodology. You can tune the performance of your vSphere environment, assess performance. So obviously, just like Windows have performance tools, their big performance application is actually SCOM, System Center Operations Manager. That is a very expensive license as well in Microsoft. Its alternate here in VMware is vRealize. vRealize is also a big application that is one-stop monitoring application plus automation, monitoring and automation, right? And it has its own separate license, pretty huge application there. So you can tune the performance of, but we're talking about the performance tuning methodology, and that is the inbuilt tools within vSphere for performance tuning. We have seen that in when we went for monitoring, when we tried to check the performance of CPU and RAM for ESXi directly as well. So assess performance, use appropriate monitoring tools, record numerical benchmark before changes, identify the limiting resource, make more resources available. So that's obviously in monitoring, you would go for it. Resource monitoring tools. Many resource monitoring and performance monitoring tools are available for use with vSphere inside the guest OS. So that would be your Linux guest OS and Windows guest OS, and within that, whatever tools you already know. Perfmon is also famous for performance monitoring. Task Manager shows you live performance of your machine, of your operating system, and then some Linux commands if you're an expert in Linux. Outside the guest OS, vCenter server performance charts, vRealize operations, vSphere ESXi system logs, and RESX top and ESX top are the command line tools there as well. So if that. So I'll just log into this and we can check the monitoring sections there. Monitoring and performance sections. Normally it's a live performance related screens and dashboards are already there, abundant of them for a lot of resources. So I'll just try to connect. Okay, so while it is loading, so and I have the other two machines up. Actually, two of them up, not the third one. So it's gonna detect that E6i3 is right now not open. When we are talking about the performance tools, there is monitor here, and if we go to menu here, so I'll just click that. So tasks and events, especially events would show what's going on there, if we check out on the cluster level, so there is monitoring available, and monitor has a lot of sections there that would show what's going on. I'll just make it full screen here, and if we go to the data center level, so there is monitor on the data center level as well, which also still shows issues and alarms and performances, task and events, cloud native storage, container volumes. So if we go for triggered alarms, suppose, so it is showing obviously our environment related alarms. So there's critical for the local data store. Local data store we stopped using, and host connection, power state. This has been happening. E6i3 related error was there, but we already have. I mentioned already that I did not start the E6i3, so we could just check all the tools wherever we need E6i3. I will just start it. So if we are on the data center level and monitor, then there is cluster level and monitor, and on the E6i level, if we go then there is the same monitor as well. Obviously, the environment that you have chosen on the left side is, it's going to show the performance and monitoring and events and alarms for that particular resources on that level. Okay, so if I go above here, cluster level, and then click the monitoring, and there's triggered alarms also there, and any of the alarms, suppose there's a host connection power state 46I2 which is actually connected, and this alert is 3 April, so last time, while today's 10, so this is an old one. Suppose I click inside this, so host connection power state, no compatible host for secondary. Maybe it was shut down or it was restarting, so it may have given this alert because of the time and date showing here. That's pretty old itself. So 6 February. So host TPM attestation alarm. TPM, trusted platform module, is where you save your encryption and decryption keys. There's an add button here as well, alarm definitions, and if I click the add button here, so and that's you want to have any alarm set up that you should get an alert for, and it should be emailed to you or SMS to you if you have connected all the other notification systems and mechanisms to the vCenter. Suppose you have an Exchange server, email server, that is, that you have given the address, SMTP address, to this, then obviously it will send you an email as well. So suppose there's a CPU threshold alarm that I want, and or target type is clusters, because I enabled it on the cluster level, although there is virtual machines and host related alarms that you can create as well. Suppose I go for virtual machines, that I want an alarm to be configured for the virtual machines. I named it this, but I haven't selected the actual alert there, so I'm just going to click next here, and then it says the if and then. It shows that if this happens, then do this. So in the if section, if you go there, select a trigger. So what kind of trigger would you want to have an action done against it? So VM CPU usage, suppose it's really sky high. So VM CPU usage, if select an operator, is above, is below. So if I go for is above, and then suppose you go for 75%, for how long? So for 5 minutes or 10 minutes, or even more, whichever you want to select. If that's the case, then what do you want to do in response to that? So there's a trigger, the alarm, and severity level. So it could be warning, show as critical if it's more than 75 or 80%. So 75 is there. Then send email notifications. Obviously, you need to give that SMTP address there, or SNMP traps if you have configured the SNMP traps. Normally are they collect information of performance of different counters that are related to hardware and software applications on operating systems. So if you have created the SNMP traps, then it will send you those. Then there is a run script here, or in reaction to what happened above, which is the CPU reached more than 35% for 10 minutes. Then in reaction to that, do you want to run a script? So these are, you want to be just notified, or you want to be notified plus run a script as well, or just run a script. So, and then there's add advanced actions, and that is migrate VM, power off VM, power on VM, and reboot. So what you want done in response to, you want to run a script, you want to actually have some action done here. Normally DRS is there. If there is some issue there, DRS would simply move the application or virtual machine to the better host already, right? So if DRS is there, and DRS is expensive, so companies with budget would be able to afford that. Others would just do these alarms and put some actions there as well. Okay, so if so yeah, that's the whole concept about alarm. I mean, we can set it up. This is the same thing for Windows as well, for Linux as well, that you have an alarm and you define a condition, and then what is the action you want in return for that, in exchange against that. So it would be either notification or a script run, and or script run, and or an actual action taken as a result. So obviously I would want to migrate that machine, but we have configured DRS that actually does that. If we haven't, then obviously you can do that. So alarm contains all these kinds of questions, right? And yep, it depends on what we select, and then you can go ahead and next and finish. So this is just to show that how alarms, more custom alarms can be created for whatever you want to see and know. I'm gonna go back here to, so vCenter server performance charts, vRealize operations. vRealize operations would be an application, enterprise grade application that would require separate licensing, and it is huge. Like when you install it, it's like a 4 hour, not 4 hours, sorry, 45 minutes up to an hour of installation. It requires its own data store. It requires its own database. Actually, the SQL Server database needs to be deployed. So just like a vCenter level enterprise grade big application, you deploy there for central management. So you can do that with the vRealize as well, but it's for monitoring and automation, right? So if I go ahead and vRealize for vSphere, what is vRealize suite and vCloud suite? So, or suite. So there is Essential Cloud Management with vRealize suite and vCloud suite. Enable seamless cloud management with VMware vRealize suite, or add vSphere for vCloud suite. Through a single suite, you can maintain consistent app operations and governance for your hybrid cloud environment, and access all the automation. So access all the automation and operations capabilities. So it does offer vRealize. When you deploy, it does offer scripting as well as automation that would be, so it just this machine requires a 16 GB RAM virtual machine. It's an appliance. First of all, vRealize is a appliance, and that it can monitor not only your VMware vSphere environment, but also Fusion environment of VMware, as well as Microsoft Azure Cloud, AWS Cloud, Google Cloud, Linux environment, Microsoft just separate Hyper-V environment as well. So pretty robust and comprehensive tool for any kind of environment you have in your company. This tool recognizes it, and it has the monitoring capabilities to send monitoring related alerts from all those other non-VMware environments as well. So that's why it's pretty expensive. And the good thing is, you can see on the top right here, there's a try hands-on lab as well for this VMware vRealize. So I'll just put that link here as well. Obviously, that's their own controlled environment where they can. So vRealize monitoring and automation. Also has on lab, possibly 30 minutes or 40-minute lab on their own machines on this link. So there's that hands-on lab-related information for vRealize. What is vRealize Suite? VMware vRealize Suite is a cloud management solution. It integrates VMware vRealize cloud management products that together provide automation, operations, log analytics, and lifecycle management on premises. So just like Microsoft has SCCM on-premises System Center Configuration Manager that pretty much does monitoring as well. Actually, monitoring is a separate tool, SEOM, but SCCM does the deployment, upgrades, updates, changes of any type, thousands of machines on premises and in the cloud. So that's what VMware has created a solution as well. That you want to make any change, you want to deploy anything, you want to update anything, then you go for vRealize Suite, and hence its licenses. Because of that, it is expensive. So that is lifecycle management on premises. We did the lab for patch management as well there. Then there is the vCloud. VMware vCloud Suite is an enterprise-grade cloud infrastructure and management solution. It combines all the products in vRealize Suite and adds vSphere, the industry-leading computer virtualization platform. So vCloud basically is that you have your own hardware. You purchased, suppose, heavy duty, maybe 50 servers, right? On top of that, you install vCloud yourself, and you then offer, your company to create virtual machines in that vCloud infrastructure. Now, that vCloud can connect to also to the actual public cloud from other companies like Microsoft Azure, AWS, Amazon Web Services, which is the top in cloud service providers, and Google Cloud, and also Oracle Cloud. So, but it's just software that you install on your hardware. It's a pretty extensive software, and only recommended hardware, tested hardware from VMware is going to work with this. So, and this is also called private cloud as well. So what vRealize Suite and vCloud Suite deliver DevOps for infrastructure. So DevOps is obviously you infrastructure as a code. You need to know some coding there, and suppose you want to create 20 virtual machines and 3 virtual switches and a lot of other configurations. So you can just create a code in DevOps, development and operations, and then run that code, and it will create your infrastructure as well. So and self-driving operations, modern infrastructure automation, data center virtualization, vCloud Suite only. Again, you need to download the software on your own hardware and then simply run the vCloud and connect it to other public clouds as well. But main of its features are vRealize automation, vRealize operations. So automation would be increased agility, productivity, and efficiency through self-service automation. You want to automate whatever you spend half an hour in. You want it done in a few seconds. You are always, suppose you're creating a test environment every month, new test environment or the same test environment, but then you want to get rid of it as well. So you can automate that, and so you're transferring some virtual machines or always migrating some virtual machines at a specific time, you from one particular host to another on specific days. You can automate that. So there are many automation related capabilities or scenarios where you're doing it manually. Why don't you automate it? vRealize operations, optimize, plan, and scale, SDDC, software-defined data center. Well, what we were working on till now is a software-defined data center. We deploy vSphere and vSphere vCenter, and this vCenter is the whole software-defined data center. When we say software-defined data center, SDDC, so we're simply talking about everything that a data center has physically that can be virtualized, that is virtualized already. So what does physical data center has? Servers, switches, networking equipment, fiber channel, and so that is all already converted or virtualized already into software. So you want to have SDDC operations, which is to deploy virtual machines, deploy ESXi hypervisors, deploy switches, connect with the distributed switch. So you're all doing that with vRealize operations. So vRealize and log inside it will collect all the log files from ESXi hypervisors, and then lifecycle management. It's a full deployment and upgrades, enhance environment stability, and improve end user productivity. So that lifecycle manager is you want to patch, you want to also check all the configurations, you want to deploy configurations, and you want to keep them consistent as well. So then the lifecycle manager is used, but vRealize can also really help with it. So we were talking about the vRealize operations, and that's a full appliance that needs to be deployed, and a separate license have to be purchased and connected to vCenter. So minimum is actually 16 GB RAM, but and then it's going to take 45 minutes to 1 hour to deploy it. vSphere ESXi system logs. So obviously all the log files that you that are created from there, you can try to check out what's going on. Normally, if we connect to our hypervisor here and to it, and so view system logs, there is syslog on the right side, then there is VM kernel, to config management agent, then there is host D is a management agent, virtual center agent, VPXA, VMware ESXi observation log, VOBD. So press the corresponding key to view a log, press Q to return to this screen. So if I just press enter here and 1, so now I'm in side here, there's a quit showing there, and reg exp, and then there's help here as well. So this is showing some of the performance there, executing start plugin, and how it is connected to iSCSI, the current configuration as well. So if I go for so I click the H, and then it tells commands marked with asterisk may be preceded by number n. Notes in parentheses indicates the behavior if n is given. So display the help, and then forward one line is this, all that, okay. And then, so normally these are for more or for more, so return for more, which is enter, and Q when done. So I'll just so I'm just entering there and then Q, and slash, and then we can try to give some commands there as well. If I go for the commands, so let me just grab some there. So before that, I'll just simply call backspace Q and view system logs and sys logs, right? Before going there, if I go to the VM kernel, I went to actually config and virtual center agent. So I'm going to go stick to syslog and grab some commands there. So let me just grab some. So configure syslog on ESXi hosts, configuring syslog on ESXi, and viewer ESXi syslog configuration. So there it is, and manually configure ESXi syslog location. So normally where the log files and how to read them all are what they're showing here, and on this page we offer quick access to all list of, okay, that's just showing videos there, list of tutorials, ESXi installation, USB installer patch. That's pretty much the whole installation for ESXi. That's one I was going for. I'll just go for this. So there is, you can use the vSphere client or the ESX CLI system syslog command to configure the syslog service. Information about using the ESX CLI system syslog command and other ESX CLI. So this is all the VMware ESX CLI commands, and so there you can just run those commands for maximum number of archives to keep. You can set the number globally and for individual subloggers. If we go for where the log host, okay, there it is. Remote host to which syslog messages are forwarded, and port on which the remote host receives syslog messages. So you can include the protocol and the port, for example, SSL : and the host name UDP. So with this command, you can connect to the log files with the help of, if the ESX or SSH is open first of all, and then you can try to check the logs there. So it gives you a little information about that. I'm just gonna put that here as well, but I'll show you how to connect to the ESX CLI and then run some of the commands there to check whatever you want from command line. So I'll just so ESXi system logs. Also, F2 to here. To view various troubleshooting mode options like enable ESXi shell, enable SSH, and restart agents. So this is the troubleshooting options here. If I enter there, enable ESXi shell is there, and ESXi shell is disabled. Enable SSH. So ESXi shell is what? ESXi shell is where you can give commands and do whatever you can do by clicking up in the GUI mode. So in ESXi shell, you can do with commands there. There is that. I just pressed enter and it is enabled, right? And enable SSH, so that is just secure shell. This is also disabled. I pressed enter there, and it also shows enabled here. Then there is modifying ESXi shell and SSH timeouts, DCUI idle timeout. So when does the direct console user interface really is timed out and you're not using that, and it should just stop or lock. So restart management agents. These are all the management agents or services that are letting you connect from the vCenter and are running in the background all the services that is running the ESXi itself. So we have enabled for ESXi to this ESXi shell, and let me grab one of the slides there. Okay, let me quickly grab that. set of commands there. So we have already enabled the ESXi shell, and from Windows actually we need to connect. So that's what I'll just grab one from Windows machine. And ESXi7. So let me just give me a sec here. I'll quickly do that. Okay. Let me. So while it is, I'll just grab the document. We will just check it out, some other services, and then I'll show you how to connect to that. Because we need to really then download the file, and let me just grab that file from on Windows from where we can connect. We can use PuTTY as well, and there are other ways as well. So let me just get back here and cover others while then we will connect to ESXi shell as well after downloading the file in Windows. There is ESXi system logs that we can grab from the ESXi when you connect through ESXi shell. But other than that, there are two commands there as well that can be also given in ESXi shell to grab performance information. So guest operating system monitoring tools, yes, we know that it's Task Manager. But if we go ahead, well, within Task Manager, if you have done this before, that you've opened the performance monitor, so Viewer is just saying that you can create 4 guest operations. For guest monitoring, you can just go through this performance monitor. Now, this is something you may have done in your Windows server, that you can go to perfmon and simply create those data collector sets or performance monitor, and then go to the counters, and then it will just give you all the information in the event viewer as well as here. So that's the within the guest that Viewer is suggesting that should be configured. But other than that, so there's using ESX top to monitor VM resources. Suppose you want to actually go for the command line tools to actually run the commands that gives you monitoring details. Although we realize as a well, that's a huge application that can give you just same monitoring related information plus automation. But when you go for command prompt related, some users are always or administrators are always comfortable with command prompt, so they would just simply like to go that way. So what does it do? That's what we need to know. And for the exam as well, the ESX top utility is the primary real-time performance monitoring tool for vSphere. Can be run from the host's local vSphere ESXi shell as ESX top. So this is like a perfmon in Windows that you can simply run, and then it will simply start giving you this information, which it already shows in the Windows here, in this screenshot here. And then can be run remotely from vSphere CLI as well. So there are 2 ways to from the command line. You can connect 2 ways to vSphere. One is ESXi shell. The second is vSphere CLI. vSphere CLI also can be downloaded from into your Windows or Linux machine, whichever operating system you are using. There's ESX CLI and download. So ESX CLI would have the command lines for PowerShell as well as for Linux. You could connect their standalone ESX CLI. Suppose we go for CLI 7.0. ESX CLI, yeah, software download. So how to download and install async drivers? No. So ESX CLI installation of NCM now. So I'll just remove this 7.0. Normally it's just a command line that you can download installation and VIP. So, but you can install it on the Windows, and then you can simply connect from ESX CLI to your hypervisor and try to configure. Well, you can run then simply all the commands that you can. You can do patches as well. Obviously, if you are a command line guru and you want to do everything command line, although the graphical versions are there for all these tasks in the vCenter, but if you want to go command line, then obviously there is that. So so as I said, C and shell. So normally when you connect, you have to give that to which hypervisor and what kind of package you want to deploy from there, and then this is just showing how to deploy a driver through ESX CLI. Suppose network driver, suppose display driver, suppose some other. So we were talking about ESX CLI. I'll try to grab a file there, and also ESX shell there that we need to see. So I'll be showing you that. But what we need to know from here that within that, if you want to perform, if you want to have performance, analysis done through command line, so there is ESX top, and the same thing is done with our ESX top when you're doing that with vSphere CLI. Works like the top performance utility in Linux operating systems. In this example, you enter lowercase c and uppercase v to view CPU metrics for VM. So they do run the commands to then show that what for the virtual machines, all the performance, how would you see that when you run those commands. And monitoring inventory objects with performance charts. So that's again vSphere statistics subsystem collects data on the resource usage of inventory objects, which include clusters, hosts, data stores, networks, virtual machines. So if I go to the vCenter and within the monitor for the cluster, I'll just make it full screen. So cluster or ESXi host, as it was talking about, suppose I click the ESXi host there and there is monitor, so all issues. Then there is performance, and performance has overview here, and that's giving you then the performance statistics, and for real time or last day, last week, last month, last year, custom interval. So, and other than that, overview, network adapters, disks, or virtual machines, what you want performance for, right? So I've selected virtual machines here, so CPU usage for that and memory usage. If I go down, so there's disk usage and network. I don't have any virtual, actually I have one virtual machine up on, so that was P2B. So yeah, P2B went, last lab went on for half an hour more, I guess, or 45 minutes more, and it was successful. So this was a machine that got created. In fact, this is taking memory, so I'm just gonna, hopefully you have tried P2B. Yes. So overall performance, you can see from here, real time, advanced if you go. This is also giving you more real time information. and that is 350, 355, 4 o'clock, 4:05, 4:10. So every 5-minute performance, what's going on for whatever you want here. And tasks, so whatever tasks are done here, I just powered off Win01. So yeah, that task is showing here with timestamp and more details. So pretty comprehensive performance related configurations are showing there. Hardware health. Hardware health is obviously we don't have actual hardware under our E6i, so that's why it is not really going to detect anything. It's not an actual hardware. It's obviously nested virtualization. There are storage sensors. So, but it does connect to the sensors that are placed on the VMware certified hardware. So whichever VMware hardware is in the HCL hardware compatibility list of VMware is what the information of that hardware can be retrieved from these sensors here. And then there is Skyline Health, and so online health availability, customer experience improvement. So that is again the thing that we did not select when we were deploying it. That VMware wants to collect information from you, and then put their software better. So for that, they are showing. So other than that, okay, I'll go ahead. So working with overview performance chart. So we just saw that you can just check for E6i1, suppose the charts, and we visited that. You just need to confirm that where you have to go for that. Advanced charts support data counters that are not supported in other performance charts. So we just saw that data counters are there if you have kind of your E6i is actually deployed on a hardware, then you would get much better report than our test environment, and that would be all automatic as well. You don't have to do anything manual. And vCenter server stores statistics at different specificities. Time interval, real time, past hour. Well, that's just we saw just that you want statistics for last week, last month, last year. So it grabs all that information from the log files. So chart types, bar and pie. Depending on the metric type and object, performance metrics are displayed in different types of charts, such as bar charts and pie charts. And that is on the data center level, and also, and that is showing under performance and overview. So we have visited that already. Performance, yeah, this is performance and this is overview. But there is nothing to show. That's why it is. If I go for host, network adopt. Okay, disks. Okay, so that's some charts showing there. Where the disks, line chart. So yeah, we saw that already, but you can check out and configure that. Chart types line, yeah, line charts, we just saw that. A line chart displays metrics for a single inventory object, for example, metrics for each CPU on E6i host. Chart types stacked charts are useful for comparing resource allocation and usage across multiple hosts or VMs. So there's a view custom here in real time, and then in the advanced actually it's showing there, which we already went to. Per VM stacked graphs. So every virtual machine based performance you can see. Yeah, we selected virtual machines, and yes, it can give you per virtual machine. When we say per virtual machine, so I select the virtual machine here, and then the monitor, obviously the same charts are for one virtual machine as well, that you can see. Advanced, well, there is nothing here because it's not even started. But obviously this same monitor tab is for virtual machine, for hypervisor, for cluster, for data center, right? So whatever level you want to see the performance, it will show you. Saving charts, you can save charts as PNG, JPEG, SVG, some pretty basic stuff. Objects and counters. So performance charts graphically display CPU, memory, disk, network, and storage metrics for devices and entities managed by vCenter server. Objects are instances or aggregations of devices. So examples: VCP0, VCP1, VMHBA, storage adapter, right? Aggregation of overall all NICs. So it would just combine multiple NICs or combine multiple vCPUs and give you overall performance as well. Counters identify which statistics to collect. Examples: CPU, use time, ready time, usage. For network, it would be network packets received, memory swapped. So the counters would give you specific information, statistics, and here objects are instances of aggregation. So it combine overall performance will be given here in this example. If we about statistics type, so statistics type is in the unit of measurement that is used during the statistics interval. Rate, data, delta, absolute, so value over the current interval, changed from previous interval. So delta always obviously is whatever is changed, and then there is absolute value independent of interval. So that's how they really go for statistics. About rollup is the conversion function between statistics intervals. 5 minutes of past hour, we saw that already, that every 5-minute performance was showing there in the chart. So you can just make it 30 minutes of past day statistics are converted to one past week value. 6 5-minute statistics are rolled up into a single value. So every 5 minutes it gives you performance, or you can also go for 30 minutes and check it out, that what is the performance for that possible time. Monitoring resource use, and it still goes for interpreting data from tools. So vCenter server monitoring tools and guest OS monitoring tools provide different points of view. Again, kind of we just saw that. It shows the task manager screen as well as what we saw there already. CPU constrained VMs. So continuously high, the VM is constrained by the CPU. However, the host might have enough CPU for other VMs to run. So overall, it's saying that yes, CPU can possibly have it's the VMs can have CPU constrained situation, and in that case, it will show that in the charts as well. I mean, like, kind of basics stuff. Multiple VMs are constrained by the CPU if the following conditions are present: high CPU usage in the guest OS, relatively high CPU readiness, value support. So overall, how to read the values and how would they look like in different situations. So if memory is constrained, it will look like this. If CPU is constrained, it will look like this. That's what they are showing here. And if a VM consumes its entire memory allocation, the VM might be memory constrained, and you should consider increasing the VM's memory. So this is just saying that it's always like this. It's showing that straight line. This means it's always needing more memory, and you should consider increasing that. So overall, it's just showing that what different shapes look like. Memory constraint hosts any evidence of ballooning or swapping is a sign that your host might be memory constrained. So if ballooning is happening, and we talked about ballooning and swapping, that spare memory is taken away, some of the spare memory is taken away from the machine that is not using it obviously, and it's taken to that machine that really needs it now. And when that machine which needed the RAM is done using the RAM and doesn't need it, so the memory is then put back or returned to that machine which had that spare memory. So ballooning is just that, okay, just let the spare memory from one machine to be used. But that if that keeps on happening, that's what they're saying here, that ballooning and swapping is happening. So what you do, this means that your physical host is not able to offer much here, and you need to increase the memory of the physical host if ballooning and swapping is happening a lot. And disk constrained VMs. So we talked about CPU constrained VMs, that they have less CPU, and then memory constrained, that they have less memory. Then there is disk constrained as well. Disk intensive applications can saturate the storage or the path. So if you suspect that a VM is constrained by disk access, take these actions. Obviously, change the disk or get a better one, have more. Measure the throughput and latency between the VM and storage. So the thing is that from virtual machine, how much data is traveling to the storage, and then how much data is being processed, like IOPS, like input output data per second, how much read and write is being handled on what speed. So you need to see all that. Use the advanced performance charts to monitor throughput and latency, read rate and write rate, read latency and write latency. So if it's really putting a burden on IOPS, input output, or read and write, so that means a lot of read and write is going on. Either you get a better SSD disk or just increase more, so data could be spread across more SSD disks and not overwhelming few. Monitoring disk latency to determine disk performance problems. Monitor two disk latency data counters, kernel command latency and physical device command latency. And these two counters would show you that the disk latency is occurring, the data is being processed a little late, and that's causing the degradation of performance. Suppose you're retrieving some data, you've done some search and it is retrieving data from the disk, and that is going slow. So then in that case you can go for these two counters there in the performance monitoring. And network constrained, network intensive applications often bottleneck on path segments outside the ESXi host. For example, WAN links between server and client. So yeah, if WAN are slow, obviously you will get it slow as well. Verify that VMware Tools is installed and VMXNet 3 is the virtual network adapter. For example, WAN links between server and client. If you suspect that a VM is constrained by the network, take these actions and measure the effective bandwidth between the VM and its peer system. So, what is the bandwidth of the on WAN in one branch of the virtual machine to the other branch when the data is transferred? Check for dropped received packets. So, total network related monitoring you need to do. How much bandwidth is available, how much data is being dropped, and what kind of network card you've connected to the virtual machine. Are VMware tools installed? So this would be some of the points that you need to. Monitoring virtual machine performance, well, that can be done on the guest level as well. Yeah. If using alarms, in fact, I just showed the alarms before we reached the alarms here, but you go to monitoring. Yes, we were here just now, triggered alarms, and then I went to an alarm, and then how to create one, and what does they ask? What do they ask in the alarm? Well, this is the screen we went through. We click the add button here, and then what actions you want against what event happened. This pretty much is the same for Microsoft Azure, AWS, Linux, Microsoft, whichever application you go to. You can create an alarm, and if this happens, then do this. Notify me, run this code, and take this action. So that's normally are the options for any alarm anywhere you configure. uh, and yeah, on the so there are alarms shown on the vCenter level as well, and new alarm definition. So that again asks the same set of questions. If this happens, what to do? Yeah, we just went through this. Well, definition of alarm, a trigger, can monitor the current. Yeah. So we actually went through these rules. So I'll just go ahead. Yeah, we saw this. Okay. Using alarms, we have created one. And okay, so that's normally what we see in resource monitoring. And so I'm gonna go for another one here. So we talked about some of the storage, but we'll talk some more about storage as well. And there's storage concepts, fiber channel storage, iSCSI storage. We talked about that. We did the whole labs there. So some of them we have already done, and some of them we need to discuss. And for the exam purpose as well, and obviously for covering the topics. So storage concepts, we have talked much about it already. There's a data store, and on top of the data store, you can have so a data store is a logical storage unit that can use disk space on one physical device or span several physical devices. Data stores are used to hold VM files, VM templates, and ISO images. Yeah, we did that all. And vSphere supports the following types: VMFS, NFS, vSAN. So VMFS and vSAN we have used or configured. vSphere virtual volumes and NFS. So what are those? So NFS basically is any Linux-based device. So suppose you go to your computer shop and you purchase 4 disk or 8 disks or maybe 20 disk NAS device there, and so NAS is network attached storage. So you just it has an Ethernet card. You just connect it with Ethernet cable and make it available over the network. It's storage. You can, but it's Linux based. So NFS network file system is there. So you can just create a data store on NFS as well. NFS based volumes. You can create a data store on top of Linux based volumes as well. But it does not support all the VMFS features. Some of the VMFS features. So, but suppose you ran out of space and you have many Linux machines or you have network attached storage as well. So you can just temporarily use that as well, extra storage. If we go ahead, storage overview. So you have all the ones on top of which there's direct attached storage, fiber channel over Ethernet. There's iSCSI. We have used iSCSI there, and over the Ethernet you can connect to these LUNs, or over the fiber channel / Ethernet you can connect to that. And you can use VMFS. We've been using that. That supports all the VMware features. Then there is NFS, vSAN, and vSphere virtual volume. These are the other types that you can use. vSAN is direct attached, so it's the local disks that you were using, and vSAN cluster you create. So we tried that. vSphere virtual volume. So this is normally, if you want to use vSphere virtual volume, you must have an expensive SAN solution already there in the market, in your data center. So on top of this, you can create virtual volumes. So you don't have to really go to the storage guys. Hey, storage guy, can you make that storage available for me and let me know when it is there? But with virtual volumes, there's another layer attached to the storage, and the VMware administrator has more control over that storage than when. But you must have that SAN purchased SAN solution already to use this. So overall, there are these data store types are 4. and then there are storage protocol overview. Each data store uses a protocol with varying support features. So there's VMFS, data store, storage protocol, fiber channel. So obviously VMFS you will use for all the VMware features. Fiber channel, boot from SAN support, yes. vSphere vMotion support, yes. So it supports all HA and DRS when you deploy a fiber channel. Fiber channel over Ethernet. So, okay, there is a fiber channel. That is the fiber channel. Fiber optic cables are placed from your storage to your ESXi hypervisors, and there are HBA network cards, fiber channel network cards there on the physical servers. If that's the case, then this is whole fiber channel network. And there's a fiber channel over the Ethernet. Suppose you have Ethernet network and you have a fiber channel backbone for your storage. So even with the Ethernet network, you can take fiber channel. It's enveloped in a frame, and it travels over the Ethernet as well. So it's obviously not as fast as fiber channel because you don't have the actual fiber hardware. You have Ethernet network, Ethernet cables to which through which you are actually connecting. So, but you can take fiber channel packets, frames over the Ethernet network as well. And then iSCSI, that's purely over Ethernet that you can work, and it supports all the advanced features. SAN, boot from SAN support, vMotion, HA, DRS, it all supports that. And then there are other types, NVMe of RDMA. This is another storage protocol which has certain features and certain not. DAS, which is then SAS, SATA, NVMe, all kind of types of disks are supported. But if you are putting data stores on local disks there, so what kind of features it supports and what it does not. NFS is Linux based, so there's certain features supported there. The main features which are required are supported. And vSphere virtual volumes, this is you really actually need. It says iSCSI and Ethernet as well, and NFS as well, but fiber channel is main usage where it is used. vSAN data store, we have deployed that, so that is also vMotion, HA, and DRS. But we don't have the. He deployed it until where the test environment allowed us, and all the configurations you can test on an actual hardware. If you have that many hardware devices like Dell servers there, then you may see some of the errors would be gone from there. That really require an underlying hardware to be detected first. So about VMFS, we talked about that. So SXI hosts support VMS 5 and 6. VMware file system, right? So features supported by both VMFS 5 and 6, concurrent access to shared storage, dynamic expansion, on-disk locking. So these are some of the features there. Dynamically expands there. Disk is locked. When you lock the disk, it's you can make it readable, or you can make it not to be deleted as well. Delete protection, right? And then there is VMware 6 4K native storage, so it's even more IOPS are supported there from the VMware side, and automatic space reclamation, so it reclaims whatever unused space is there to be provided to. Sometimes it's called also white space, where actually data is not, it's just occupied with not temporary data, which is TMP files or unnecessary data that the software can recognize and remove as well. They're just used temporarily but left there instead of being deleted. And about NFS, so NFS is a file sharing protocol that ESXi hosts use to communicate with a network attached storage NAS device. NFS supports NFS 3N 4.1 over TCP/IP. So NFS is Linux operating system related network services. So if you want to use Linux related disks, or if you go for the NAS devices that are all having Linux OS in it, installed there, so you want to create a data store on top of that, then you can have a data store created there as well on a Linux device. What it does not support is NTFS. Obviously, it's a Microsoft based, so it would just support NFS, which is network file system. Uh, and about vSAN, so vSAN is hypervisor converged software defined storage for virtual environments that does not use traditional external storage. So it's just not external storage; it's the internal. We talked about that in detail. We did the whole lab and configured it step by step. But you can have HDD, flash, SSD disks there, and vSAN data store would be composed of minimum 3 up to 64 hypervisors. We talked about that in detail before. And virtual volumes. So vSphere virtual volumes provide several functionalities. Native representation of VMDKs. VMDKs, the virtual disk of a virtual VMware virtual machine, right? So, native representation of VMDKs on SAN NAS, no LUNs or volume management, and there's works with existing SAN NAS systems, so it does work on NAS as well. A new control path for data operations at the VM and VMDK level. So normally the VMware administrators have a bit more control over the underlying storage instead of requesting uh, that something be done from the storage administrator. More control is given to the VMware administrator there. And snapshots, replications, and other operations at the VM level on external storage. You take a snapshot yourself, replications, and other operations that the VMware administrator would otherwise do, or they do VMware administrators. So that can be done directly on the specified storage instead of um, asking the. So yeah, instead of asking the storage administrator to help out with some of the operations there. So automates control of per VM service levels by using storage policies. So it provides then some storage policies there. And suppose you want to create a virtual machine on a storage that is having all SSDs, and then there is some data stores that are created on top of HDDs or HDD SSD combined. So a data store with pure SSDs, only SSDs, and data store with um, HDD plus SSD. So you can then create storage policies, and through those policies, suppose you're creating a virtual machine that has a database, and that really requires a lot of SSD processing. So you would assign a storage policy to that virtual machine, and that storage policy will direct that virtual machine to be created on top of the data store that is on top of SSDs itself. And So the standard access to storage with the vSphere API for storage awareness protocol endpoint. So vSphere API is application programming interface for storage awareness protocol endpoint. So virtual machines are made more aware of what is the type of underlying storage they are being created on, and they could know through storage policies that is it slower storage based data store that I'm being created on, or is it faster storage based data store it is being created on. So storage containers that span an entire array. So it huge amount of storage containers can be made available that the virtual machines can control and do their day-to-day tasks of replication, snapshots, caching, encryption, and deduplication. So basically, virtual volumes would be deployed on ideally, normally they are deployed on SAN, and more control is given to the VMware administrators to do their day-to-day tasks instead of communicating with the storage administrator to request some of the permissions and tasks to be done. So raw device mapping, although not a data store, raw device mapping RDM gives a VM direct access to a physical LUN. The mapping file -rdm.vmdk that points our VM to a LUN must be stored on a VMFS data store. So now that is very interesting, because the concept here is for raw RDM or raw device mapping. So you have one virtual machine here. Well, suppose this is the ESXi, and you have a virtual machine on top of that, and that virtual machine is connected. Its virtual disk is connected from SAN. Suppose there's SAN ones coming here, right? And there is so now first of all, the current situation, suppose the virtual machine is having its virtual disk on top of this LUN, and so obviously it's not directly installed on the LUN. It is actually on top of a data store. So there are layers that needs to be crossed for the data to be read and written, right? So that's the data store. Now the data is traveling, like when there's a read and write going on. So there's a writing, there's a reading. The IOPS are it really you have an application that is really IOPS intensive. So it would be suppose you're installing a database, right? So that is really input output data per second intensive. So now the data is being read, so it goes through that's to the virtual disk, the request, and then the virtual disk request when it's input output. So the input output request goes to the data store, and then it goes to the LUN, and then data is read and or written. So basically you're writing on top of LUN, obviously, but you have to go through these layers for huge amount of data to be read and written, right? So read and write or input output data per second. So what about suppose the application actually is having degradation of performance now, that okay, so there's a lot of read and write going on. It's a database, right? So huge amount of data is there, and there are so many people who are searching something, and data is being read a lot. So the reading means reading from the disk. So a lot of read requests are hitting this virtual disk, in turn data store, in turn LUN. So a lot of work is going. So how about, and not this, there's one more, like this is going on, but then there is another virtual machine and another virtual machine and another virtual machine, and they obviously would share a LUN, a data store, a LUN based data store with other virtual machines. It's not just this data store is not just for one virtual machine. Obviously you would have it for other virtual machines, so their reading and writing also affects the overall performance of that database application, where a lot of read requests, search requests are hitting, uh, and there's a lot of users who are connecting here, but so are users connecting to these machines and to these and to these. They're all also doing read and write. So overall read performance is really bad for this machine database application. So because this data store is being shared by other machines, so its overall performance is slow. How about, in order to avoid this, we could have another LUN deployed, and that whole LUN, which is whole raw LUN. So raw LUN means that you are not sharing it with anyone else, and it's raw. Raw LUN also means that you don't even create a data store here. You don't format it with anything. Raw LUN. You just attached it from the SAN, and that's it. You haven't done anything. You didn't create a data store on top of that, and you provide this raw LUN only to this virtual machine. Hey, the virtual machine with database, you wanna have a raw LUN with direct performance reads and writes, so you can format that LUN and install your application here, and this whole LUN is dedicated only for you. This is called pass-through disk in Hyper-V, and this is called RDM in VMware, that you provide a virtual machine a second disk, which is actually a full raw LUN. Not even data store is provided there. You just can use that raw disk as you want. Suppose you want this operating system is Windows, right? So suppose you want to format it with NTFS. Yes, you can do that, and then deploy a database application on top of that. And that database application does not have to go through virtual disk and then the data store and then the actual LUN. It's just directly writing on the LUN, and this LUN is not even shared with any other machines. This LUN is just dedicated for this one VM's application. So then the performance obviously will be very, very good. So that's raw device mapping, that you can make a LUN available for the virtual machine, and that virtual machine then gets direct read performance from this LUN. So if and so that is what it's showing, that full raw LUN is created for this RDM here, that is not shared with any other virtual machine. So but the concept we talked about there. Physical storage considerations. Before implementing your vSphere environment, discuss the storage needs with your storage administration team. Consider the following factors: LUN sizes, I/O bandwidth required by your applications, I/O requests per second that a LUN is capable of, disk cache parameters, zoning and masking. That is for on the SAN side, that you zone or you carve out a LUN, that okay, I have a 1 terabyte LUN, and I am just giving you 200 GB out of that. So you just then you use zoning and masking for that. There are other procedures as well. Multipathing setting for your storage arrays. You can have multiple paths coming to your virtual machine or data store from your SAN. If through one path you are down, you're not connected from SAN, you can connect through another path as well. Export properties for NFS data stores. So these are some of the configurations there that you can check out. And then they talk about fiber channel storage. So there is fiber channel stores VM files remotely on a fiber channel SAN. Obviously, so first of all, it's an expensive solution. You have fiber channel HBAs here, which are network cards, which are compatible with the fiber channel cables, and you're connecting the physical servers through fiber channel connected network cards to the fiber channel connected SAN. And a fiber channel SAN components. A SAN consists of one or more servers that are attached to a storage array using one or more storage system. Using one or more SAN switches. So you would, when you're really configuring a fiber channel solution, so you would have fiber channel switch. You would have HBA or network cards connected to host bus adapters. Normally, it is called host bus adapters. You connect through those to the fiber channel switch with fiber channel cables or fiber optic cables, and those switches with fiber optic cables are connecting to your disk array. So from the host through the switches to the SAN, you're connected there. Storage subsystem, physical hard disks, LUNs, logical unit numbers that are created on top of carved out of the actual physical storage, and SPs, storage processors, which are really putting your data in and out from storage, and fiber channel switches, the fabric fiber channel switch here, and then there is servers with host bus adapters, HBAs. So that is all all the equipment that you need, and the diagram just shows how it really works. And then there is fiber channel addressing and access control. So you use worldwide WWN or worldwide name unique 64-bit address assigned to fiber channel node. So that worldwide name through the storage processor is, and then there's zoning you can do done at switch level, used to segment the fabric or fiber channel traffic that you can zone, or you can try to segment the traffic that this HBA or this host related traffic is going to only this set of LUNs and disk arrays in turn, and this host traffic should only go to these LUNs and should not be going or refer to these LUNs here, right? So you can do zoning for that, or segmenting, or telling the switch that, okay, keep the traffic separate, please, coming from this host to this LUN, and this host to those LUNs. And LUN masking here done at a storage processor or server level, and makes a LUN invisible when a target is scanning. So you want to mask the LUN. Suppose your host is searching for LUNs there. You don't want certain LUNs to appear in the search to be selected. Maybe that LUN is actually having less capacity, or maybe that LUN is having underlying storage that is slower, and you don't want it to be appearing in the search, so you can do LUN masking as well. So that's fiber channel addressing and access control. Other than that, there is multipathing with fiber channel. So as the name says here, it's multiple paths going on. So there is LUN 0 here, and there is storage processor, and this LUN is connected to this switch to this host, and this LUN 0 is connected through that switch to the same host. So the host has to have two host bus adapters or storage connectors or network cards that are connecting through fiber switch, and LUN 1 also is connected to switch A, switch B, both, and through that to the host with HBA1, HBA2. So obviously, two paths to connect to the host, connecting the host to the LUN. One path goes down, and the host is still connected to the same LUN through the other path. So that is called multipathing and the traffic is also load balanced this way. And if one host goes down, or one path goes down, then the other path, or through the other path, still the host is connected. The virtual machines are still connected to the LAN and working fine. So that's multipathing. Okay, guys. So let's take a break and then come back um, and continue with our topics. And if you have any questions, even from the document, you can send any questions, email me or WhatsApp me, or we can discuss it in next class or today's class as well. Okay, let's take a break. All right, resuming, and so guys, in this downloads folder, this one, I've added that link, and you can download all the slide decks, all of them, from VMware. So these are all the slide decks there. So this is the link for all the slides. I'll continue now. And we were talking about the storage. Also, I can put it in the chat as well. Okay, now we're continuing to talk. So fiber channel over Ethernet. So we were talking about multipathing, and we understand that these are the multiple paths that are taken by that a host to the LAN, and it's not only failover. It doesn't not only do the load balancing, but it also does the failing over of the path as well, and just okay. Now, if we talk about fiber channel over Ethernet. So if your host contains fiber channel over Ethernet adapters, you can connect to your shared fiber channel devices by using an Ethernet network as well. So that's slightly cheaper than the full fiber optic equipment, and that would be that you have Ethernet network as well, and you want to use that too. So in that case, the fiber channel packets or frames. So as it says here as well, the fiber channel traffic is encapsulated into FCOE frames. So this means that the pure fiber channel traffic does not totally depend on only fiber optic cables, but even on the Ethernet network also the fiber channel traffic can travel, and that is really good relief for the customers that does not have a very big fiber channel network there, and do have Ethernet network there as well. So these FCOE frames are converged with other types of traffic on the Ethernet network. When both Ethernet and Fiber channel traffic are carried on the same Ethernet link, use of the physical infrastructure increases. So obviously, Fiber channel traffic is also added, and you already have an Ethernet traffic. So in that case, the use of the physical infrastructure would be increased. Fiber channel over Ethernet also reduces the total number of network ports and cabling. So obviously, the same fiber channel packets are traveling over the Ethernet as well, so you don't have to open a lot of other ports there as well. So, well, this is a bit cheaper solution uh, to adopt, and so connecting the VM kernel to the physical fiber channel over Ethernet NICs that are installed on your. So obviously you must have those specialized network cards that do support fiber channel over Ethernet, and the VLAN ID and the priority case class are discovered during fiber channel Ethernet over Ethernet initialization. The priority class is not configured in vSphere. ESXi supports a maximum of 4 network adapter ports for software FCOE. If we go over to the host here and to configure, and here we have software adapters and add software adapter. So there is the add software fiber channel over Ethernet adapter as well. Discover software fiber channel over Ethernet adapters associated with the following physical network adapter. So obviously, if you have those fiber channel over Ethernet network adapters, then only you can configure it. But this is just fiber channel. If you have on the other side fiber channel or fiber optic cables, fiber optic switch, as well as the SAN. You have a SAN actually that has a fiber channel, fiber optic cables connected there as well with host bus adapters or HBAs on the SAN side. Then you would go for this option, but it is here in vCenter. And yeah, so that's where we were just now. So it's also showing exactly this. And okay, so if we go ahead, iSCSI storage, we talked about that before as well. Learner objectives. So we're going to go for iSCSI components. And iSCSI SAN consists of an iSCSI storage system which contains LUNs and storage processors. Communication between the host and storage area occurs over a TCP/IP network. So the main thing is that the main point to understand here is that it's not going to be fiber channel, obviously. So if you want to configure the whole SAN over your Ethernet network, then you go for iSCSI. There's iSCSI storage subsystem and disk arrays. Physical hard disks are there. Then there are LUNs that are carved out of the space that the physical disk provides, and then there is storage processor that processes the storage. TCP/IP network over the Ethernet, that's the main thing. You don't have any fiber channel here now, so it's just Ethernet network, and then servers with iSCSI initiators. So we talked about that. We did that iSCSI initiator. We connected our software SAN with that target there, iSCSI target in the labs. So iSCSI addressing, it's IQN iSCSI target name IQN dot this whole long name that it's a storage name as well as your domain and or computer device fully qualified domain name plus the storage ID there. So iSCSI alias store 1 IP address, so whatever IP address you have there, and iSCSI initiator name. So target name is this and initiator name is this. We already know that what is target. Target offers disks while we were creating that in our lab, and initiator requests this. That is the ESXi host. Target is in our case it's a server 1 where we installed or configured our iSCSI SAN. And storage device naming conventions. So storage devices are identified in server based. Runtime name uses the VMHPA and CTL convention. So this name is not persistent through reboots. So the main thing is that the naming convention that it uses when we did connect to the storage devices, so it had those naming conventions using their target, uh, identifies the iSCSI target address and port, and then target is just offering the disk. One, a unique identifier is designated to individual or collections of hard disk devices. So LUN would be a unique identifier designated to individual or collections of hard disk devices. A logical unit is addressed by the SCSI protocol or SAN protocols that encapsulate SCSI, such as iSCSI or fiber channel. Well, anyway, so that's that volume that gets connected to our E6i hypervisor, which is comprised of one or more multiple disks. And iSCSI adapters, you must set up software or hardware iSCSI adapters. Yeah, we did that. So to access iSCSI targets, your host uses iSCSI initiators. Yeah, so you can refer to the whole lab where we did step by step all this. And E6i network configuration for IP storage. A VM kernel port must be created for E6i to access software iSCSI, and the same port can be used. So you can have a separate virtual switch related connection also created to the SAN. We didn't have to create that. We didn't use a VM kernel port to connect to that, but we connected to our iSCSI SAN separately, directly, in fact, not through the switch. And normally when you're connecting to the storage, it's always better to, just like we were doing our best practices to introduce VM kernel port for vMotion and for fault tolerance and for vSAN. So we can really, whenever we are creating a VM kernel port, obviously that's what they're saying, that just give it their own two network adapters for high availability and better traffic management and load balancing. Activating the software iSCSI, yeah, we did. So it's just showing screenshots of what we did already in the lab. Discovering iSCSI targets, yeah. So there's static and dynamic. Normally we connect it to dynamic, but static just means that if you have created multiple targets there, one target having 50 disks with it, and other target having 20 disks with it, and third target suppose having 200 disks there. So whichever target the initiator connects to will get that initiator will get that many disks that the target brings with it. And we connected 3 disks to our target, but there could be multiple targets having their own number of disks as well. So then statically you can select which target you want to connect to. We had just one target, so we went for dynamic. And iSCSI security, so there's CHAP here, challenge handshake authentication protocol. iSCSI initiators use CHAP. So we talked about that this just when you're sharing disks, it just pops up as, hey, are you the one that I'm sharing disks with? So you just need, if you want some extra security there, you can just put extra username password. In our lab, we did not put any extra username passwords there. Multipathing with iSCSI storage. So software or dependent hardware iSCSI uses multiple NICs. So if you are going for multipathing, this diagram we already talked about before as well. It's just giving a bit more detail here that each NIC is connected to a separate VM kernel port. Each VM kernel port binds with the iSCSI initiator. Independent hardware iSCSI uses 2 or more hardware iSCSI adapters. So the thing is that if you want to have multiple paths going from one host to the LUN, or LUNs it's connected to, so you can do multiple pathing for that. Binding VM kernel ports with iSCSI initiator. Again, we did do that with port binding. Each VM kernel port that is connected to a separate NIC becomes a different path that the SCSI storage stack can use. So this is multipathing that they are also giving steps for, so this is I don't have a lab for that, but I'm planning to create this lab as well for multipathing, or whatever lab is available. I'll just give a link if you want to see that step by step as well. And accessing iSCSI storage, yeah, so we were able to access that, and we did all the other labs because of that iSCSI storage that we created. And then it's talking about VMS data stores, VMFS. Creating a VMFS data store, yeah, we created so many. So not much here. You use data stores for browser, yeah. We put ISO image there as well. A lot of stuff there. It goes up to 64 terabyte. And overcommitted data stores. A data store becomes overcommitted when the total provisioned space of 10 provision disks is greater than the size of the data store. So thin provision, suppose you give 1 terabyte, and now thin provision is like whenever you install something, then only it takes that much space. Otherwise, it doesn't take a lot of space. But you did give in thin provisioning maybe 1 terabyte, and your data store is 500 GB space based data store. So that is also, they're saying, overcommitted. Like you're not actually implementing, or you don't have that kind of software to take the whole 1 terabyte space, but you're still overcommitting in the sense that you're still saying, oh, I'm gonna go up to 1 terabyte, but right now currently I'm not taking any space because of thin provisioned deployment. To actively monitor data store capacity, set alarms. So it's just saying that, okay, you put 1 terabyte space to thin provisioning, still just put some alarms. Maybe you keep on, after 6 months, you put some more software there. Maybe you put AutoCAD there. Each AutoCAD file sometimes is very big as well. So, and you've been collecting those files locally, saving it locally. So in that case, you would not know when it has gone, or it has tried to go ahead of or more than 500 GB. To reach the 1 terabyte, which it won't, but it will then occupy all space on data store, and your virtual machines and all other virtual machines will be also will stop working. So to actively manage data store's capacity, so just keep an eye on the data store capacity, view motion away the virtual machines before the data store fills up. So common practices there, just put an alarm and keep an eye on the data store when it fills up. Increasing size of VMFS data stores, yeah, increase VMFS data store size to give it more space or to possibly improve performance. Yeah, you could just expand the data store there as well. Data store maintenance mode. So there is a maintenance mode on the data store level as well. Before taking a data store out of service, place the data store in maintenance mode. Before placing a data store in maintenance mode, you must migrate all VMs from there. So if I go to the storage here and to the data store that we created, if I right click here, so there's unmount data store, and there's a maintenance mode for the data store as well. Okay, so it was referring that here. No, it's just a separate feature that it's saying that it is there. Deleting or unmounting a VMFS data store, and an unmounted data store remains intact but cannot be seen from the hosts that you specify. So if you unmount it, obviously the virtual machines, when you're creating a virtual machine, this data store, unmounted data store, will not show among the data stores that are there. So obviously that's, and deleting a data store. A deleted data store is destroyed and disappears from all hosts that have access to it. The deleted data store permanently removes all files on the data store. Obviously it's deleted. Multipathing algorithms, again it discusses that arrays provide active and active passive storage processors. Multipathing algorithms interact with these storage arrays you have a storage area, which means that there's a long list of disks there, and you want actually active or active passive multipathing, which means that either both are active or only one is active and other is actually passive. So your data is moving through one path here, right? And if that one path goes down, then your storage just fails over to the other path. So that would be in multipathing. You can have active and active passive as well, just like we had virtual machines that were active, which were active passive, primary and secondary, basically we call them in fault tolerance. Configuring storage load balancing. So in path selection, policies provide scalability, round robin availability, most recently used and fixed. So in data store, when the multipathing is configured, you can also do active, which means load balancing will occur, or active passive, where only one path is being used. And then it's all about the VMFS data stores. So that is okay. NFS data store actually, and an NFS file system is on a NAS device that is called the NFS server. So basically, it is NFS data store, which is either a NAS. We just talked about that. So either it's on the NAS device or on a Linux machine. Now we can create an NFS data store example on our Windows machine as well, because Windows also provides NFS shares, right? So if it is, yeah, it is showing there, authentication services and NFS, and okay. So suppose we have actually a Linux machine, or we have a NFS share folder there, right? So how do we really create that NFS data store? So there's that document with the step-by-step instructions that are, I'll just upload that as well, but this shows that how to create a NFS shared folder on a Windows machine. Windows, it's supposed to be done on Linux, but also Windows supports Linux NFS shared folders as well. If you want to interact with a Linux machine on the other side, and here it's a Windows machine, so Windows can talk Linux as well in terms of copying files. So you can just create a NFS data store. So this is the document that shows all the steps. I could just quickly pull it off as well, like do it. So I can just go to our Windows machine, which is the Win01, and I'll go to the server. So first you have to just in order to have an NFS based data store, you have to have an NFS share first. In order to install NFS share, you need to have a either Linux machine, or you can create that NFS share in a Windows machine as well, right? So the objective of this lab is to create a NFS data store. So we've been creating data stores on VMFS data stores till now, right? What about NFS data stores? So Linux-based data stores, which does not really offer all the VMware features. So if I go to the add roles and features for NFS share, first we will create an NFS share here, and then we're going to create a data store in VMware on top of this one. So if I go to next, and it's inside the file and storage services here, and if I go to file and iSCSI services, so there's the if we go down, server for NFS, so this can create a NFS share that can help us create a NFS data store. If it has an NFS share, then obviously you can create a data store on top of this. This share has to be over the network just available. I'm just going to click restart, although it doesn't require a restart. Install. And then we can create a shared folder on top of Windows, but that would not be SMB that Windows uses, it's NFS that Linux uses. What? It's best to add more features on this website. The restart. Oh, okay. So it requires a restart for some reason. That's why it's not installing the feature. I'll just restart quickly. Oh yeah, on top of this Windows we also installed the backup software, so it's getting slower. Alright, so I'll just quickly deploy that NFS share and then create a data store on top of that NFS share. I think it's loaded, yeah. So we go to roles and then in the file and storage services here, then file and storage services, and then go down to server for NFS. Select that, add features, and then next. Well, there's next finish after that. So I told it to restart if it needs a restart, but it didn't. That's very strange. You're kidding me. Again? Okay, the operation cannot be completed because the server that you specified requires a restart. So, you know what? I'll close it and reload the pressure. Next. Oops. Let it load, and I will not click that restart button automatically thing. Okay, crash. So it is. Next. Okay, so yeah, if it says it's it needs a restart, I think it's going to. Now only let me go ahead when it gets a restart again. So just okay. Really? Okay. Okay, I'll try again without putting that restart button. File and storage services, and I'll go for server for Netplus, add features, next, and just install. Okay, so, okay, bad day. Okay, so it's stuck with something needs to be, I started 2 times. So I am putting that whole document, you can do step by step there on the link. So downloads, okay, here, NFS-based data stores, we'll talk about that, but I'll just quickly insert the Okay, so I'll insert. Uh, so that step-by-step document will how to configure NFS-based data store, and so we were talking about that, and um, yeah. To configure an NFS data store, create a VM report for better performance and security. Separate your NFS network from the iSCSI network. Create the NFS data store by providing the following information. So it then goes through the wizard, and basically it asks for a path, which you can only get when you are creating uh, NFS. When you've done creating an NFS data store, NFS share on a Windows machine, or if you have a Linux machine and you know how to create a manifest share, then you can do it from there as well. If we go ahead, yeah, so that's this is all the steps that these are all the steps that come, that authentication services. So everything's in the step-by-step document, that what you need to select and what you need to put there. It's a virtual machine and the share name basically, and then the authentication, you can allow anonymous authentication there. And so there's unmounting an NFS data store. Yeah, you right click it and simply unmount. So they have mentioned that too. Multipathing and NFS storage. So for a highly available NFS or NAS architecture, so that's cheaper architecture that is Linux based. Configure NFS multipathing to avoid single points of failure. Example of a multipathing configuration: configure one VM kernel port, attach NICs to the same physical switch to configure NIC teaming, configure the NFS server with multiple IP addresses. So NFS server has to be there to better use multiple links. Configure NIC teams with the IP hash load balancing policy. So these are some of the recommendations there. If you want to have multiple paths going to the NFS storage, that is less performing than the SAN, but obviously cheaper, and smaller companies do use that as well. So NFS 3.0, and then there is 4.1 version as well for NFS, and it's well, kind of same procedure there, that you need to give an IP and you need to give the share path where the share is existing, and they're just giving. Then there's vSAN data stores. We talked in detail about vSAN data stores. So this is just a theory of that, and it just uses local disks to create aggregated data store, vSAN aggregated. So it comprises of the local disks of minimum 3 hypervisors, and we talked about that before, so in detail, and you can refer to that whole lab. But disk groups you have to create there. Disk groups are vSAN management constructs on all ESXi hosts in a vSAN cluster, and a host can include a maximum of 5 disk groups. The disk groups are combined to create a single vSAN data store. So that was created there when we created it. Now, obviously, if we have original underlying hardware, then the results would be all good. In a nested environment, we can go up to where we can configure it, install it, configure it, and the vSAN data store shows itself. As the version of VMware vSphere is increasing, it's their requirement for the creation of a data store, of a vSAN data store, that is, have the requirements have increased. So, like even more better hardware, better hardware is needed for really showing the vSAN capabilities. But we were able to configure the whole thing. Suppose you want to configure that with you actually have a that kind of hardware. Suppose in some companies you were able to grab that kind of hardware. So the steps are exactly the same what we did here. because these are the same steps. And a few courses ago, an administrator had a test environment. Actually, he was lucky to have a test environment there in his office, and tested exactly the same steps there. So everything works fine. So the thing is that if there's an actual environment, you will see the results, but we are near enough with our available environment there. So other than that, uh, so vSAN hardware requirements. So it is talking about the hardware. vSAN capabilities are native to ESXi and require no additional software. And so yeah, one SSD for caching, SSD HDD, at least one SSD for capacity, or HDD for hybrid model. If you have HDD, then you can use that too. We did use that, and I showed in the lab how to use it and how to change an SSD to look like HDD while actually it is SSD. So 10 GB NIC. So these are all the requirements that we talked about in our lab as well. Now, if okay, yeah. So I'm just gonna go ahead a little viewing the vSAN data store summary. Yeah, we created that vSAN data store when we were done with our lab. It looked like exactly like this, and we confirmed that it is connected to all three hosts there. Yes, it was connected to all three hosts, and so it says here objects in vSAN data stores. vSAN storage is object based and policy driven. VM created on a vSAN data store include the following objects: one VM home namespace, one or more VMDK objects, thin provision VM swap file there, and memory file, and performance data objects there. So all these are the names of the objects, and when they are created, how what are the extensions there. So vSAN related information is this. And storage policies define how objects that are included in a VM are stored. Storage policies have the following characteristics based on storage capabilities defined for a VM or disk at the time of deployment. Can be applied later, can be changed at any time, cannot be deleted if they are in use. So how do they look like normally? If I go there to the environment, and I restarted it 2 times actually, and while it connects, let's see those. Okay, so yeah, it's connecting. And suppose you're creating a virtual machine at that time, the storage policies do appear there as well. And I've just gone through creating a virtual machine here to just show that when it reaches the storage, so there is that storage policies that appear here. Manage storage policy: large, regular, single node, stretched, thin. So VMware has created some background default policies there, that if your environment is really large, or if it is a regular environment, so what kind of optimized configurations should be implemented for the underlying data store. If it's just a small single node environment, or single node machine for which the data store single node, and then stretched here. So suppose stretched is when we were creating vSAN, and it is that you're stretching vSAN to multiple data stores. Then if it is a stretched environment, then how the background storage settings should be optimized to work the best. So they have created some storage policies according to how we are. The default is what we normally stick to, unless we have these kind of storage policies. If vSAN was created or virtual volumes were created, then you would just select those policies, and in the background it will just automatically configure it to work that way. It will just simply optimize the underlying hardware to be used in a way that the performance, the most performance can be retrieved. So if we okay, so using a vSAN data store, yeah, we already did that. Lab reviewer. Okay. So we also need to talk about security and some of the topics of security as well. So let me grab that security related info. And okay, so trust anchors. I'll be creating trust anchors there. Sorry, just a sec. Yeah, so there is another topic here, which is about trust authority, vSphere trust authority, and how does it really work, the overview of the trust authority. So I'll just grab that documentation, and it's a new feature or mechanism, we can say, that what is vSphere Trust Authority, how it works, and what are the concepts behind that. So if we go for Trust Authority and okay, so with VCP7 and later, so it's totally new in 7 that there's a trust authority that has been created. But what's the concept behind that? And it is pretty much related to TPM, Trusted Platform Module, where the concept is that we save our encryption decryption keys in a chip inside the motherboard of a physical server. Those encryption decryption keys are there for the disk that has been fully encrypted. The protection is that suppose somebody takes out the disk from there, and that disk is encrypted, and its encryption decryption key is not in the disk but in the motherboard of that physical server. So if the disk is taken away from that motherboard, it will be all encrypted and secure. The data will not be lost unless there's some very advanced decryption tool there. I don't know. So vSphere 7 and later, you can take advantage of VMware vSphere Trust Authority. vSphere Trust Authority is a foundational technology that enhances workload security. So enhancement of workload security is the point here. vSphere Trust Authority establishes a greater level of trust in your organization by associating an A6i host's hardware root of trust to the workload itself. So ESXi hosts hardware root of trust. So as I was saying that there is that TPM. Normally when we type there TPM chip, normally it's used for BitLocker, and so it would be inside a software inside the chipset, and that would just simply have your encryption decryption keys available, right? So vSphere Trust Authority concepts and features. If I right click and open that, so vSphere Trust Authority secures your SDDC, so software defined data center. So it secures your software defined data center against malicious attacks by extending the trustworthiness of a trusted computing base to your organization's entire computing infrastructure. So, okay, it's still, lots of fancy words there, but what does it mean? vSphere Trust Authority uses remote attestation and controlled access to advanced cryptographic capabilities. Okay, vSphere Trust Authority is a set of services that satisfies high security requirements. With vSphere Trust Authority, you can set up and maintain a secure infrastructure. You can ensure that sensitive workloads run only on ESXi hosts proven to have booted authentic software. Okay, how vSphere Trust Authority protects our environment? That's the main thing. Then, first of all, we understand. Okay, it protects our environment. It's somehow related to TPM, but again, how does it work? So there's this link here, and you configure vSphere Trust Authority services to attest your ESXi host. So first of all, these services, Trust Authority services, will attest that your ESXi hosts are legit ones or they are secure and it's okay to work on top of them, which then become capable of performing trusted cryptographic operations. So the ESXi host then performs all the cryptographic operations which can be trusted now. And what are cryptographic operations? You encrypt a disk, you encrypt a virtual machine, you encrypt data in at rest, or you encrypt data that is in transit or moving. So you're doing those encryption and decryption because the trust authority has attested your ESXi host. Yes, now you can do all the encryption and decryption. I authorize you and I attest you. So that's what Trust Authority is doing, but how does it work? So vSphere Trust Authority uses remote attestation for ESXi hosts to prove the authenticity of their booted software. So when they start, then Trust Authority not being on the, so we talked about TPM chip, right? That is on the motherboard actually, on that hypervisor hardware. But this is not on that motherboard. This is a separate vSphere entity that is remotely trusting it is actually authorizing, it's proving that the authenticity of the boot environment. If the ESXi boots and has no malware, no malicious tools, no rootkits, it is attesting that yes, this ESXi booted without any malicious software, any other kind of malware or rootkits there, or boot's file attack was not done on this. So it's attesting for the booting of ESXi host. If it is a clean boot, if it's a safe boot, then yes, then there's a trust there that whatever next operations the ESXi host will do are all safe and secure. So attestation verifies that the ESXi hosts are running a authentic VMware software. Nobody cracked it. Nobody put some kind of backdoor there. So attestation verifies that ESXi hosts are running authenticating authentic VMware software or VMware signed partner software. Or a partner software that is VMware signed. Attestation relies on measurements that are rooted in a TPM 2.0 chip installed in the ESXi host. So it does talk to the TPM on the local machine's motherboard, and whatever measurements the TPM has done. So TPM already has the encryption decryption keys of the host. So this trusted root authority talks to the TPM. Hey TPM, on that motherboard of E6i1, are you good with the security configuration? Or you're keeping the encryption decryption keys there? Are you good with that? Is there any problem with your process? Are you having some threats there? If TPM confirms no, I'm okay, and yes, I'm good. So then the vSphere Trust Authority simply retrieves that information, and it's a cross check, and it also relies, not only cross check, it also relies, the Trust Authority relies on the reporting of the local TPM software on the motherboard, and then says that okay, what TPM says on E6i1's motherboard, I attest that, and yes, you're secure now. Go ahead, do your stuff with a peace of mind, right? Peace in. So in vSphere Trust Authority, an ESXi can access encryption keys and perform cryptographic operations only after it has been attested. So they have just enhanced that process. Before it was just TPM locally storing the encryption keys. Now it is enhanced into, hey, Trust Authority, please talk to the TPM. Maybe there are 200 hypervisors, right? So Trust Authority talks to all 200 hypervisors, physical machines, motherboard, TPM, that hey, just give me the report and let me authenticate that report and test that report if that report is good. And then, yes, we all have a peace of mind there that these hosts are okay, they're booted okay, they can do their encryption decryption safely and securely now. So Trust Authority is all about collecting reports from local TPM and attesting those reports that yes, this is correct and you're good to go. And so vSphere Trust Authority glossary, and then glossary there, and vSphere Trust Authority introduces specific terms and definitions that are important to understand. vSphere Trust Authority glossary. So vSphere Trust Authority specifies a set of services that enables a trusted infrastructure. It is responsible for ensuring that ESXi hosts are running trusted software and for releasing encryption keys only to trusted ESXi hosts. So this is the main task of Trust Authority: confirm that the encryption decryption keys are in safe hands. The TPM chip on the ESXi host is functioning correctly. It is not facing any threat. It has not been compromised. It is working as expected. It is secure. So Trust Authority simply certify that. Okay, you're good to go. And let me check the other host. Oh, you're also good to go. Okay, let me check the third one. So that's how the Trust Authority really works. vSphere Trust Authority components. The vSphere Trust Authority components are attestation service and key provider service. It also keeps this encryption and decryption keys itself as well. Attestation service attests the state of a remote ESXi host. So pretty much we should be able to understand by now that it simply attests that if the host is securely booting and the software is secure, there's no malware and no threat there. That's mainly the purpose of the Trust Authority, right? And it's newly introduced in 7 version. So this was not in any previous version. It was a totally new feature. Uses TPM 2.0 to establish a hardware root of trust and verifies software measurements against a list of administrator approved ESXi versions. So it just cross checks that if TPM 2.0 is exactly configured the way it is and it's not facing any threats, and yeah, it's working fine. So that really tells, this one line really tells the attestation process much more clearly. So I'll just put that as trust of authority um, attestation. Okay, so if I go back, key provider service encapsulates one or more key servers and exposes trusted key providers that can be specified when encrypting virtual machines. Currently, key servers are limited to the KMIP protocol. So there's a key KMS. Maybe you've heard about KMS, Key Management Services server. So that it provides, it saves the encryption keys for wherever they are used. So that key provider service is also actually handled by Trust Authority that has been newly introduced in VCP7. Trusted infrastructure. A trusted infrastructure consists of a Trust Authority vCenter server, a workload vCenter server, at least one vSphere Trust Authority cluster configured as part of the Trust Authority vCenter server, at least one trusted cluster configured as part of the workload vCenter server, encrypted workload virtual machines running in the trusted cluster, at least one KMIP compliant key management server. So that's a, for small companies, they might not even go for that because it requires some processing of the virtual machines also. But bigger environment would really appreciate that with big budgets that can actually create that cluster of trust of authority. In fact, vSphere Trust Authority basics. So there's that diagram that in this. So it says here in this figure, and here's the vSphere Trust Authority architecture. The following figure shows a simplified view of the vSphere Trust Authority architecture. vSphere Trust Authority. So here, vCenter server systems. One, right? So Trust Authority Administrator connects to the vCenter server, and E6I host running Trust Authority services that it is connected to, and Trust Authority Administrator is connecting here as well, and it's connecting to TPM 2.0 attested E6I host. So this is a normal, way. Daily the host is connected, and the other one is connected to the assisted ones. So vCenter server systems, separate vCenter server systems manage the Trust Authority cluster and trusted clusters. Trust Authority cluster consists of E6I hosts that run the vSphere Trust Authority components. So if there are E6I hosts that are connected to the vSphere Trust Authority, so that is called Trust Authority cluster. Key servers store encryption keys that are used by the key provider service when encryption operations are performed. So there are these virtual machines that can handle the Trust Authority the software there, and would execute all the processes there. And the Trust Authority is also, it's actually living inside the vCenter itself and vCenter 7 only. And trusted cluster consists of the E6I trusted hosts, which have been remotely attested with a TPM and that run encrypted hosts. So first of all, obviously, you would have a original hardware, and in that, suppose you purchase Dell servers, right? So the vCenter, inside the vCenter 7, the Trust Authority would communicate with that TPM on each physical host, and then if it can communicate, obviously, then it can basically work. So these are all the terminologies there, and this page really tells it all about the Trust Authority. But basic idea behind that is that it's going to communicate with the TPMs of all the hardware hosts, and confirm from that TPM reports that the E6I booted without any malicious software. It was not compromised, and it has securely booted, as well as whenever the encryption decryption is required. So it is providing those encryption decryption keys to the E6i hosts as well. So that's the trust authority for vSphere trust authority, and the basic concept about that. If we go to, so I've uploaded all those slides already. I didn't change anything, so don't save. Now here we have already talked about some of the topics of vCenter, centralized management with vCenter server, and whatever review is going on. So, and whatever review is left, and any questions from your side, we can handle in next class as well. Plus, I need to tell you in detail about the vouchers, as well as the exam, how you can do that, and better to give it as fast as possible. And you can also let me know any other time on WhatsApp or email that if you need that newer file of the sample questions. So because they also change as the pool of question change in the exam, so the sample question file also kind of change, or they update that. So anytime you can just send me an email again, or that hey, is there a new file with newer questions, so I can send you right away before you, especially before you're about to give the exam, or maybe 2-3 days before that, or a week before that. They can contact me. Okay, do you have the newer sample questions? And I'll send you. Right. So, so this is, but we're going to talk about it in detail in next class. Next class may not be long unless you have questions there, and and whatever review is left. So review and any topics. So here about the vCenter server management platform. So yeah, we have talked about that before as well. It's hardware there, vSphere, E6i on top of that, all the virtual machines that are being handled centrally by vCenter server. And yes, it's an appliance, and it depends. It's on Photon operating system. It's it's a totally Linux-based machine. So we talked about that. PostgreSQL database, vCenter server services, and then vCenter services include a lot of features there, or include services include vCenter server, vSphere client, vCenter single sign-on. Single sign-on was that when we deployed the Veeam software, remember? So so we were able to just log in through Veeam to the vCenter. When we deployed P2V software, so P2V was also able to see the vCenter infrastructure within the environment. So license service, it includes vCenter lookup service, VMware Certificate Authority, content library, E6i dump collector, which is all the dump files or log files that it collects. When you deploy vCenter server appliance, all these services are included. And then this is architecture. We have been creating diagrams of that. And the client, through the client, you connect to the vCenter. Through the vCenter, you connect to the whole environment. We've been doing that a lot. And single sign-on. There is Kerberos, just like behind Active Directory in Microsoft, there is Kerberos, which is a ticketing authentication system. So there's Kerberos here behind vCenter single sign-on as well, and certificate authority. When you purchase a certificate in $200 up to $2,000, any security certificate that you want to deploy across the environment. And then there is VMware Directory Services, which is directory services just like Active Directory. You can have users, groups, and organizational units there, right? So there's directory services here as well. and we did connect it to Active Directory as well, and you saw that we created users and we created group there, and that user and that group showed up here in the vCenter as well. So user logs in to the vSphere client, vCenter single sign-on authenticates credentials against directory service, for example, Active Directory, a SAML token, security assertion markup language, SAML. Token is sent back to the user's browser. The SAML token is sent to vCenter server, and the user is granted access. So SAML token normally has the information for the user, but the password is normally encrypted, so it's pretty secure, just like Active Directory. And enhanced link mode, if you want to connect two vCenters, that is called enhanced link mode. With enhanced link mode, you can log into a single instance of vCenter server and manage the inventories of all the vCenter systems in the group. Suppose you have in New York one vCenter, maybe it's a huge branch there, and or just for management purposes, and you have one in Toronto, and the two vCenters, so they would just look like this. Obviously, you have to deploy two separate vCenters, each vCenter requiring already 16 GB RAM, so even our 32 GB RAM environment won't be enough for this. And okay, so up to 15 vCenter server instances can be linked in one vCenter single sign-on domain. An enhanced link mode group can be created only during the deployment of vCenter server appliance. So enhanced link mode, if you have multiple vCenters, we had just one vCenter, that was big enough already. ESXi and vCenter communication, so it's on 443 based. This is SSL communication that is going on between those. So the vSphere client communicates directly with the vCenter server. To communicate directly with an ESXi host, you use VMware host client. So now we have talked when we're talking about the DRS and HA especially, that vCenter server has a we can I normally say daemon, but it's daemon. vCenter server has a daemon or a service that is VPXD, or an agent that talks on behalf of vCenter server and communicate with the host. Now on the host there is VPXA agent that actually talks still on behalf of vCenter server. It talks to the VPXD agent inside vCenter server, and whatever vCenter wants the host to do, or whatever policies are coming from vCenter, they're communicated to the VPXD agent in vCenter. It communicates with the VPXA agent in that particular host, and that VPXA agent talks to the local agent of the host, host D. Host D is that agent that is from the host side, talks to the VPXA, that is a representative of vCenter server, that talks back to the VPXD, which is living inside vCenter. So that's how they communicate with each other, and the whole communication is 443 based or SSL based. And vCenter server appliance scalability. So hosts per vCenter server instance, 2500 appliances, vCenter server appliance 7.0. So hosts per vCenter instance, for one vCenter instance 2500 hosts can be controlled by one vCenter server instance. Powered on VMs per vCenter server instance, 40,000 powered on virtual machines can be handled by one vCenter server instance. But registered VMs per vCenter server, so suppose they are not powered on, they are just registered or known by the vCenter instance or vCenter server, so 45,000 of those registered ones can be there. Hosts per cluster, 64. When you create a cluster, within the cluster we put how many? 2. So you can maximum put 64 hosts in that cluster, and virtual machines per cluster is 8,000. We had 5-6 machines in the cluster, so but maximum you can go 8,000. And yeah, so review and deploying vCenter appliance. So we deployed that as well, and we've gone through this. Yeah, we took care of the FQDN. So it's a very sensitive process to deploy that appliance. So we did that in our environment. Yeah, so we went to Win32 and yeah, we went to install and deployment of OVF. OVF is just, some, so in that file there's a OVF as well, and OVF is just open virtualization format, which means that you can export the whole virtual machine. So yeah, we did that over the network. That machine was deployed. So the deployment can be fully automated by using JSON, and this is just a human readable code. Templates, JSON templates with CLI installer on Windows or Linux or Mac OS. You can deploy from any of those operating systems as well. And vCenter Server Appliance stage 1 begins with, yeah, so we deployed the whole thing, and we've gone through the process already. It asks all these questions. We have gone through all these questions before, and then in the configure is everything, and we went through that all as well. So there's that that 5480, which is just the management of the vCenter itself, vCenter appliance. That is called VAMI, or vCenter Server Appliance Management Interface. Basically, management interface of vCenter, but we can also call it VAMI. And you can monitor backup, monitoring resource, monitoring vCenter, adding additional network adapters. This is just for the vCenter server appliance. And licensing. So licensing vSphere components is a two-step process. Add a license to the vCenter server license service. Now you guys, you have also 1 year, actually 2-year license available in your official VMware student portal, where you log in. And I've been introducing that in first 2-3 classes, but I will introduce that again. We'll go through the portal again. You have 1 year access to that. The email was sent to your private email, and so that is just about, and the email is from Netplus. So try to see that and try to log in. But we're gonna properly log into that, and then I'll show you again where to see the voucher when you get it. And it's sent from VMware. Once we say that the course is all done, then the VMware sends that. So other than that, there are software in that official VMware student portal that you can download. It's 2-year. The keys for 2 years, and you can just do the whole lab again. Vouchers for 1 year, obviously. And vSphere license service. So license service runs on a vCenter server appliance. The license service performs the following functions: provides centralized license management. Yeah, so provides an inventory of vSphere licenses, the license service, and manages the license assignments. Adding license keys or to vCenter server. So you add another license key, so you can go to the licensing and then licenses and add a new license there. So that's also showing there already under the administration, right? So there is menu, and there is administration, this one. And licenses, so you can just add new licenses here. Also, when we click here as well, so there is also auto deploy here, and policies and profiles. So we're gonna visit that in next class as well. But overall, what's the concept behind that? So we'll check it out. Yeah, so you can just add the licenses. It just shows you the whole step-by-step process. All the slides are there already. You can download from the downloads folder. Adding vSphere licenses, yeah, okay. So managing the vCenter inventory. So yep, that's the full inventory there. And the two vCenters, if you want to go for enhanced linked vCenters. vCenters are views for hosts, so you can have whichever view you're going to in one host. When you click the other host, you see the same view there as well. So we did that, and the data stores are shown here. We've created those as well. Viewing object. So about data center objects. So Toronto data center, Los Angeles data center. So you can just create those data centers. We created 2 data centers there, and each data center has then you can create has their own hosts and clusters. And organizing inventory objects into folders. So we create 2 folders as well, right? Objects in data center can be placed into folders. That you can create folders and subfolders to better organize systems. Yeah, we did that too. And adding a data center and organizational object to vCenter. So yeah, you can just new folder, new data centers. Very basic stuff here that we've already done. And you can tag it as well. Just create tags. All this, it belongs to this department and that department. Yeah, we did all that. And server rules and permissions. So yeah, we're gonna go for. Actually, we gave the custom roles and permissions already. Remember that we connected through Active Directory, and then we added a user from Active Directory, and then added a group from Active Directory, and then gave it a role. One user, one group was given a desktop role. User was given an VMware Active Directory user was given a VMware administrator role. So those roles and privileges we have done, but this is the review that we're going to do. So we're going to continue with this slide here, that is vCenter server. And any questions, we can go for the next class with the last one. And other than that, if you want to connect as well for any other questions, so we can just talk about a mutual time, and then we can connect otherwise as well. And so yeah, so guys, see you next week, and we're gonna start with this and some other few smaller topics, and wrap up with portal and vouchers and how to give the exam. So any questions now, let me know, or you can have questions in next class. So we'll see. We'll meet on next class then.
Have a good one, everyone.
Thank you.